Alright. Okay, so we started. You guys want to say hello? Okay, anyway, let's get started. So, limits involving infinity. And let me get the laser pointer for you guys to see. What we want to do is focus on rational functions. If I use, say we go with red. So y equals 1 over x. So you want to remember how that graph looks. The graph will look like this. And of course you have the other side as well. Do you need me to move out of the way? Not a problem. What was that? Yes, it will. Okay, so that's how y equals 1 over x looks. Now, you have to remember horizontal asymptotes. The problem that some of you guys have with horizontal asymptotes is that you figure it's a place where the graph can't cross, which is not true. Horizontal asymptote is called thank you. End behavior asymptote. And as the name implies, you want to know how the ends of the graph behaves. That's why we wrote like this. And we wrote like that. The limit as x approaches infinity, and the limit as x approaches negative infinity. So this would be clearly the right end. So we're kind of just doing a little review here. That would be the right end, and that would be the left end. And the horizontal asymptote's a line, y equals b. So it's not a line that you can't cross. It's basically just what does y approach as x approaches infinity or negative infinity. That's how you want to look at it. Now, of course, if I draw the horizontal asymptote here, which I'll do with the dotted blue line, right? We see over here, the graph will never cross the dotted blue line. You think this is funny, huh, Isabel? All right. It's kind of cool. Anyway. You guys can watch it later tonight. I don't play Warcraft, so just so you know. I don't have time for it. So, anyway. It can't cross the blue line, right? But, anyway, it's as x goes towards towards the left or towards the right, it can't cross. So anyway, what is the limit as x approaches? I won't look at you guys. What's the limit as x approaches negative infinity for f of x? Come on, guys. What is the limit as x approaches negative infinity for f of x? What will y approach as I go to the left? Y gets closer and closer. And how about if I go to the right? 0. Good. So you have 0 and 0. I think I'm going to test out the microphone on the laptop so I don't look so ridiculous trying to do this. There's a microphone built in, but I don't think it works really well. They should, yeah, they might. Yeah. Yeah, it would be kind of random. That's true. We'll play it when we're done. I'll upload it right before we leave today. So anyway, so here's a generalization. The limit as x approaches plus or minus infinity of 1 over x will always equal 0. And think about it. When x gets really, really big, you're doing 1 over a large number. What happens when you do 1 over a large number? It gets close to 0. It won't be exactly 0, but it gets infinitely close to 0. So you can also use some intuition to think about it. You can graph it, which I did. You could plug in a calculator, which I'm not going to do because obviously the people are not here, are not going to be able to see that. So we'll just stick with this. All right, next one. So this was a little weird. This is just what? What kind of graph is this? What is that?
A straight line.
Okay, well all lines are straight. What kind of line is it? Horizontal line. That crosses the y-axis at 3. So let's go to a new color. So we'll go green. So I think it should be pretty obvious. As x gets really, really big, what happens to y? Yeah, it stays at 3, right? Or if it gets really small, it's still going to be 3. So in a way, it does have a horizontal asymptote. We don't really think of it like that, but it does. Because there is a limit as x approaches infinity or negative infinity, which gives rise to horizontal asymptote. So if you take the limit of a constant function, limit of constant function as x approaches plus or minus infinity, it'll always be k. What was that? What does it say what? Oh, where? Oh, okay. Oh, okay. No. Yeah, horizontal asymptote. Okay. Let's keep moving. All right. Use graphs and tables to find the following. All right. So what we could do, I may have to do this in the calculator. Actually, I'll show you how the graph looks. That's probably better. If you were to make the graph, you are going to have a hole right there. Remember we talked about the limit as x approaches 0 of sine x over x. What did that equal again? We did this yesterday. 1, right? Equals 1. So, and it looks kind of crazy, but it does something kind of like this. It kind of like flat lines eventually. This is just y equals sine x over x. That's all I'm graphing. It is for both a and b. But this is from yesterday. Only freshman only teachers. I don't have any freshman only sections. So Halko, because he teaches algebra 1. Mr. Smart, he teaches geometry. Sophomores. Probably eventually more and more people get iPads. So we'll see how it goes. Anyway, so we have that. So let me ask you this. The graphing calculator, you just got to trust me, will look like this if you do sine x over x. So what do you think the answer would be for both a and b? What is y approaching as x gets really large or x gets really small? 0. 0 and 0. If you were to do, now if you think about it, trying to think where I can write this out. As x approaches plus or minus infinity, sine x actually alternates. What do you think I mean by sine x actually alternating? When x gets really, like, for example, if you do the sine of like 2 pi, you know that's what? What's sine of 2 pi? Okay, what's sine of 3 pi? 0 again. But in between, it jumps between 1 and negative 1, right? or actually between 2 pi and 3 pi, it will go to 1, then go back to 0, then go to negative 1, then back to 0. So as x approaches infinity, sine doesn't really have any value kind of goes towards, just kind of just jumps between 1 and negative 1. But x approaches what? When x gets large, x also gets, the bottom also gets large, right? So that's why it's just going to be 0 and 0. If you think about by inspection, as x gets really big or gets really small, sine x kind of jumps around with a whole bunch of different values, but this keeps getting bigger and bigger and bigger. So that's why it just gets close to 0. And even though it's not very obvious, there actually is a horizontal asymptote at y equals 0. Because as you go to the left or to the right forever, since y is approaching a finite value, we say at y equals 0. So another trig limit to know. The limit as x approaches plus or minus infinity of sine x over x equals 0. But remember, we talked about this yesterday. It's different than when x approaches 0. That's 1. But if x approaches plus or minus infinity, it's 0. And just understand like what's happening to sine when you're making x really big. Or, in the case from yesterday, what's happening to sine when x gets close to 0. Okay, let's try another one. I'm actually going to pause the video because I think I might be running out of time here.